Okay, so hi guys. I wanted to make this video because I did find a trigonometric problem or trigonometry problem that went a little bit over my head, but I did figure it out. It was definitely a very interesting one, and this is for those of you guys that are in trigonometry. So we're gonna go over it in this video, and also sorry for the lack of uploads. I've been busy, I was dog sitting for my sister, and I just didn't have time to record videos. So we're gonna go ahead and look at this. It's this tan of 1/2 cosine inverse of 8 over 9, and we want to evaluate this expression. So the thing that I did not, notice, and we're just gonna rewrite it here. So tan of, we're gonna say tan of, so basically tan of 1/2 cosine inverse of 8 over 9. Let me just kind of, is equal to, and I'm gonna do tan of, and let me just kind of do it this way. So tan of cosine inverse of 8 over 9 all over 2. And the thing I really didn't notice was that this is actually a how do I say it? It's a half angle identity. So if you think about it, this is the angle theta, and it's over 2. So really it kind of looks like tan of theta over 2, and where this is theta, right? So theta is basically cosine inverse of 8 over 9. So basically, yeah, so that's what I did not notice until like I saw a video where they were kind of doing a similar example with it was a different kind of problem, but they were doing it in a similar way. So we're going to use half angle identities here, and I'm going to plug in, we're going to use theta. We're going to use cosine inverse of 8 over 9 for theta. And also, I want to just clarify as well that we're going to also use the sine of cosine inverse of u, or sine of cosine inverse of theta identity for inverse trig functions. So I will go over that. So here, we're just going to make theta equal to that. And we know that tan of theta over 2, and this is theta here, and this is really just going to be, I'm going to put the two following identities, or the two following equations. So it's either 1 minus cosine of theta all over sine of theta, which equals sine of theta over 1 plus cosine of theta. It really doesn't matter which one you use in this case, because they're both the same thing. So I'm going to go ahead and use the left part here. And this is what I'm going to plug in for, when I'm going to use this identity here for tan of theta over 2. So that's basically kind of what I was saying. And again, it doesn't matter which one you use. These both are the same thing. So you don't have to use both literally. You can just use one of them and it'll be fine. But we're going to go ahead and do that here. Now theta, like I said, was cosine inverse of 8 over 9. So really what we're going to have is this. Tan of, and I'm going to do it this way, tan of cosine inverse of 8 over 9 over 2. And like I said, this is theta here. And this is going to be equal to 1. So we're actually going to do it this way. We're going to do 1 minus cosine of, and again, theta is cosine inverse of 8 over 9, right? So you have cosine inverse of 8 over 9. Like I said, this is theta here. So this right here is theta. Or I'm sorry, no. My bad. This right here is theta. So, and then we're just literally following the formula. I'm just plugging in theta in for this right here. And then over sine of theta. So it's going to be sine of cosine inverse of 8 over 9. So again, this is what theta is right here, right? So we're just literally following this formula from up here. I hope that makes sense. So then, and yeah, like I said, this is theta. So, we're going to go ahead and just simplify it from here. Now, the part that I really wanted to focus on, though, is this. We need to know what that is, because otherwise we're not going to be able to, like, you know, if we don't know that formula, we're not going to be able to, like, do the problem the way that we would want to do it. So we have sine of cosine inverse of u, and we're going to do, and there's a specific formula for that, and that is that it's equal to the square root of 1 minus u squared. So it'll be like this, right? And also, actually, I want to go ahead and just kind of do it this way instead, where I just have it like this in complete pink, because so that you guys can understand exactly what I'm doing. I don't know if I like using highlighters in this case, so I'm going to do it kind of just, you know, in the way that this entire part is just going to be in a specific color. And like I said, it's still the same thing. I'm just putting, literally color coding it, because I don't know if using highlighter is, you know, I want to make sure that it makes sense. Give me 1 second, guys. I'm literally trying to. Give me 1 second. Okay, guys, so this is what I have here. I just color coded it instead of highlighting it, so it's still the same thing. And like I said, we're doing this right over here. So I'm gonna work that out, and like I said, it goes sine of cosine inverse, and I'm gonna do of 8 over 9 like this, is equal to, and it's gonna be the following: the square root of 1 minus, and it's gonna be the quantity 8 over 9 quantity squared. So this will be the square root of 1 minus 64 over 81. And if we use kind of the, you know, if we do it by hand, we have 84 minus 61 over, or I'm sorry, 81 minus 61, or I'm sorry, 81 minus 64 over 81, excuse me. And then this is going to be equal to, so if you guys don't understand how to do with, you know, the subtracting a whole number from a fraction, I do recommend that you learn how to do that, because it's very important. This is actually going to be the square root of 17 over 81. So this is the square root of 17 over the square root of 81, which is the square root of 17 over 9. So this is what sine of cosine inverse of 8 over 9 is. So really, this becomes 1 minus, and like I said, this cancels out. So we're just left with the 8 over 9. So 1 minus 8 over 9, right? This is basically this part. And then over, and then, like I said, sine of cosine inverse, which is this part here of 8 over 9. We just worked it out. And it was the square root of 17 over 9. So that was what, this was what sine of cosine inverse of 8 over 9 was. So then you're just going to just use basic, simple arithmetic and, to simplify this complex fraction here. So we're going to have 9 over 9 minus 8 over 9 over the square root of 17 over 9. And this becomes 9 minus 8 all over 9 over the square root of 17 over 9, which equals 1 over 9 over square root of 17 over 9. And then this becomes 1 over 9 divided by the square root of 17 over 9. And if, of course, we just say 1 over 9 times 9 over square root of 17. And then finally, we will say, so, these two cancel out, this one and this one. And we're left with 1 over square root of 17. And finally, we just rationalize it. So, square root of 17 over square root of 17 on top and bottom. We're left with the square root of 17 over 17. And that, guys, is the final answer to this problem. So, I mean, of course, working it out myself, it took me a bit of time. It took me way longer than this because I was literally trying to figure out, like, what, like, how to do it, because it was definitely a challenge problem for me. But we ended up figuring it out. And so the answer to this trigonometric expression is the square root of 17 over 17, right? So that is the final answer to this problem, guys. And again, I do apologize for not uploading videos, but I really had to, I was pretty busy, so I didn't have, a lot of time to be recording videos because I had to dog sit. So, with that being said, guys, I really hope that does help. If anybody does have any questions whatsoever, please let me know. And also, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.